So this is my Hobbyweight Apex. I just got back from Seattle Bot Bash 2016. I actually won that competition. It did, however, it was kind of patched together for that event. I was planning to build a new one and didn't finish it. So I decided to just slap this together and run it. So that's why it's kind of got a lot of duct tape and zip ties holding it together. But it's also pretty beat up from its previous fights. So we can take a look at it here. Has a 5-inch diameter blade. This is a 3/4 inch S7. And it spins at about 20,000 RPM. Because of all the zip ties and tape was a pain to take off, I actually haven't opened it up since its first fight. So I have no idea what it's going to look like inside. It's probably kind of a mess. We'll find out together. First I'm going to cut off these zip ties. These are really heavy duty ones I got at Home Depot. They're just kind of to help out the screws holding on the top and the bottom armor, because a lot of them are busted or missing. So this just kind of holds everything in, including on here the battery. We'll take a look at that when we get these off. So as you can see, the main power wiring for the robot runs outside of the bot. There was no room inside for any master switch or anything, so this is the battery plug here, and I just plug it straight in. This is a little splitter I made that splits out to the drive speed controller and the weapon speed controller. Kind of ghetto, but gets the job done. I've actually got a little chunk of aluminum. It was embedded in this piece of tape. Looks like it's from a couple pieces actually. It's like that's from an opponent. Okay, so let's take off the weapon motor. The weapon motor is kind of funny. It's supposed to have a tensioner on the original design. Ended up getting in the way of the battery, and so this is actually just bolted on 2 screws up really high, which made this belt nice and tight. As with a lot of things on this robot, kind of sketchy, but it works. So under this foam, we've got the battery. The battery I used last time was a little bit taller, so it had to stick out of the top here. This one mostly fits inside the bot, but not quite. So I'll have to go ahead and unplug the motor, get the top off. You always want to tape these bullet connectors together, otherwise they'll easily just pop loose. So this is the weapon motor. It's a 40 millimeter diameter, 82 millimeter long. This one's a Dr. Mad Thrust brand in-runner. It's really extremely powerful for its size and weight. This is not, I only used this for the first time, the last competition. Before that, I was using one of these Turnigys. They worked fine. They got really hot, and this motor's actually discontinued, so I switched up brands. This one, believe it or not, even with all that damage, I don't know if you can see it, but this whole motor can right here is kind of distorted. This motor still runs. It's one of the things I like about in-runners. They can take an awful lot of abuse and keep spinning. Okay, so now let's get the top off, see what we got underneath. Here's that little Y connector I was talking about earlier. Just soldered together and covered up to keep it from shorting out. Some more Gorilla Tape to take off here. Gorilla Tape is awesome, by the way, if you don't have any. It's like duct tape, but way stickier and way tougher. This is my power light right here. It's just a Hobby King light thing that plugs into your receiver power. Makes it real easy to wire in. So right here we've got the weapon speed controller. It's a Phoenix Edge 100. This is the battery. Let's take that out. This is a Turnigi Nanotech 2200 milliamp hour. Drive motors here. These are BaneBot's P60s. They're the 26:1 ratio. And these motors are Integy, forgot the exact model I'll put on the screen, but they can handle higher voltage than the regular motors that BaneBot sells with them. And they're also a little bit more durable and more powerful, but mostly I just needed them to handle the high voltage. I'm running 6-cell in this robot for the weapon motor mostly, so I had to go with the higher voltage. One of the sketchy things we've got going on here, one of the reasons I had a little driving trouble, I used to run these speed controllers. These are the BaneBot's 1245s. They don't make them anymore, so I got a couple of bot bits controllers and burned one of those up. So the only two controllers I could use were one bot bits and one BaneBot, so that's all I had left. So they're mismatched, which makes it not want to drive quite straight, and had to do some funny business in the radio to try to make it drivable, but ends up really twitchy and not really ideal. Here we've got the radar receiver. I'm using a Spectrum AR6200. And that's about all we got in here. Pretty simple. As you can see, it's really packed in here, so that's why all that main power wiring has to go out at the top. This is all just foam to keep everything from getting beat up. Like with all my robots, you'll see none of this electronics is bolted down. Makes it a lot better for shocks and everything. So one of the things I had to repair from last time, I had a lot of broken welds. I repaired most of them with just JB Weld, which is, if you're not familiar with that, it's basically just glue. So these little triangular pieces were supposed to be welded into the corners. That holds the top and bottom armor on. A couple of the welds broke, so this was one of my JB Weld repairs. Obviously it broke. Looking inside here, I've also got a broken weld there. It's kind of covered in foam, but that was JB Weld that snapped. There's another JB Weld joint down there. It looks like it's cracked, so when I take the bottom armor off, it'll probably be falling off. So TIG welding is stronger than glue, believe it or not. Let's go ahead and take the weapon blade off. It's got a bolt that runs all the way through that keeps the shaft from falling out. So now that's out, you can see the shaft we can just push out. It's kind of tight, so I'll probably have to pound it out with a hammer or something. It's kind of tight. I think the bushings, I was having some problems with them kind of seizing up, and looks like that's what my problem is. It's normally not this tight. go. Okay, so here we got the shaft. This is my favorite shafting for all sizes robots. It's McMaster Precision Tubular Shaft. You see it's got a hole in it, so it's nice and light. It comes pre-hardened and ground. Hard to beat this stuff. You can see I've got some, this is actually a new shaft I put in for this competition. You can see it's getting a little bit of galling on it, so bushings probably need to be reamed out a little bigger. They're new bushings, they're a little tight fit. This is the weapon belt. It's a 2L size V-belt. Not really adequate for this much power. It slips a whole lot. It gets really hot. Kind of melts sometimes if I have a longer match. On either side of the weapon right now, I've got Belleville washers. They handle a little bit of side shock load, but they don't really give you any bearing capability. So what happens is when I turn, I usually lose quite a bit of RPM just from the friction there. So I'll be looking to put something better in next time. And this is the blade itself. Like I said earlier, it's 3/4 inch S7 here. The pulley is ETD 150 along with this tube here, and then those are all welded together. And then the bushing inside is a 3/4 inch oil light bushing. I'm probably running the only robot running bushings at 20,000 RPM. It's kind of crazy, but I like bushings because they don't break in impacts like bearings can. They're almost indestructible that way, and you get a little bit higher rolling resistance. But I've tried bearings once and I shattered the rollers and haven't tried them again. I might switch. It gets an awful lot of heat from the bushing, so I don't know. Okay, there is the frame. So let's take a look at that by itself. This is the base plate, 1/8 inch aluminum. I think it's 661. I'm not entirely sure, but it's had a few scorch marks from previous fights. Luckily, none this time. So this is Apex's frame. It's all 1/8 inch titanium. The whole thing. What's a little bit unique about the way this was constructed, this whole outer piece, there's a little tab that goes all the way into the upper weapon supports, and from here all the way down and all the way around to the other side, that was all one piece. It was water jet cut as a really long strip way out here, and then bent with 6 bends into that shape. So that makes it a nice strong structure, still pretty lightweight. These little gusset things in the corners are TIG welded in. At least they were TIG welded in until they started breaking off. They've worked out okay. My biggest problem with them though, design wise, is that you can see they take up quite a bit of, they bump into the frame quite a bit. I have a lot less room inside for the electrical components. The front here, these two pieces are 3 layers of 1/8 inch titanium, and they're welded together all the way around the outside. And then the inner layer that you can't really see is has a cutout back here, and then those 2 plates sandwich it. So when it comes together, these 2 bolts don't really take any shear force unless you pull straight out on the weapon support. The wedges, again, also 1/8 inch titanium. This thing's really taking a beating, so this corner got chopped off and a couple of busted welds. The quality of my welds wasn't that great in general in this. because I didn't have full argon shielding. I only had the argon coming out of the TIG torch itself. And really, to do it right, you need argon on the back side. And that was especially a problem on these welds. Trying to get some argon shielding on the back. So I'll take the wedge off. You can see how that works. This wedge is really shallow, and to get it sharp here, you can see I basically set the whole bot on a bench, not a bench grinder, a belt sander, those things, and just set this on the belt and just let it sit there for a few hours, and it shaved it down so it basically ended up matched perfectly straight with the wheels. So this is really sharp, and it gets under pretty much any wedge out there. These are cut out on the sides here, out of the top, and the reason I did that is so I could take the drive motor straight out the top quickly. It's really nice in the pits to be able to take that out quickly. Normally you'd have to, if you drilled just a straight hole, you'd have to take all the wheel and all that stuff off and then pull the motor back through this way, and a lot of times it's tricky to have enough room to do that. So how this drive motor is set up, like I said, it's just a P60 gearbox, Energy motor, and then what I've got, I'll take get you a closer look here. Okay, so there's a little aluminum tube spacer in there, and that keeps the wheel from pushing this way into the gearbox. This is a Bainbots 4-inch wheel, just the keyed one, so it's keyed onto the shaft, and then just a split shaft collar on the outside holding it on. Pretty simple. I've never had this fail. Unfortunately, this type of Bainbots wheel is discontinued now, and these are my last two in decent shape. I usually use the orange ones on this robot. They actually get quite a bit better traction, but I've ran out of the orange ones, so it's down to some blue ones for this fight. Well, that's what Apex looks like. Thanks for watching, and I'll see you on the next video.